Hello and welcome back. In previous videos we worked with different vehicles, we made controllers for them, mechanisms. To make a controller for an airplane like this one is much more difficult. If we want to do it proper way, there has to be a lot of physics involved, a lot of calculations. What I want to do is try to make a controller as simple as possible. Anyway, we cannot avoid physics completely. Some formulas has to be involved, and some parts of physics we will try to fake. In the end, we want something like arcade-looking controller. We want that movement of the airplane looks natural. But on the other side, we don't want to make a simulator. So there are many ways to do this. I will show you how I did it. You will see in this video that I used some arbitrary values for a lot of variables. For the most of them, I came out simply with trial and error. So I was trying different values to see which one is going to work better for my model. That means that for your model, you need to figure out those values by yourself. Okay, let's start. First, we need a model. I have prepared this model. It is kind of a medium passenger plane. As before, drag model and texture to your folder, and then drag model to the scene. Exactly this model you can download for free on my itch.io page. First steps are similar as before. Unpack prefab completely. Add rigid body. I will set up mass to 50 tons because that is approximately how much this plane weighs. Then a simple box collider. It is important for the physics and aerodynamics that this collider is symmetrical, so it has to be exactly in the middle. And I will add 3 capsule colliders, one for each wheel. So we are not going to work with vehicle colliders today. Again, we need to pay attention that all colliders are symmetrical. Now let's just resize the ground so our plane can have space and do some camera setup. Adjust the camera view because now we want to see far in distance. I will attach camera object to our airplane object and disable camera scripts because at these speeds that our plane goes, follow camera script doesn't work properly. I will just position camera above and behind the plane tail, and camera will simply go wherever plane goes. One important thing when we do setup like this, now pivot of our plane is somewhere between the plane and the camera. This is not good for us, it will affect physics and aerodynamics. So there is an option at the top left corner of our scene, just change from center to pivot. And now our pivot point looks natural. Let's just disable script of our track because we don't want it moving along the plane. And add some fields that are going to be useful for us. Right now we have field for speed. I will add one for altitude and one for thrust percent. I will just put them one below another. Now let's configure controllers. Create new input actions. Create new actions map. And add new actions. This time I will have two actions, one for controlling movement and one for controlling thrust percentage. For thrust we will use positive-negative binding. I will use R for raising the thrust and F for lowering the thrust. For movement, as usual, action type value and control time vector 2. Binding up, down, left and right. And for controls, I will use usual WASD. Don't forget to save asset before closing. And finally, let's add some script and do some coding. We are not going to use update loop. First, rigid body variable and loading rigid body component. Then let's introduce some float variables for speed, forward speed, altitude, starting altitude. I will explain difference between speed and forward speed later. At the beginning, let's store value to start altitude. It is going to be y component of our current position of our plane. And as before, all of our physics we are going to do in fixed update loop. We need references to our text fields. And procedures to handle user input. One for controlling the plane and one for controlling the thrust. As before, we will store input value to local variable input. That variable will be type of vector2 for onMove procedure and type float for onThrust procedure. And then I will make global variables forward, turn, and pitch, and I will store input values to them. So when user presses R, value of forward will be 1, and when user presses F, value of forward will be -1. All the other time, value of forward will be 0. It is the same for turn and pitch. Then I will use forward variable to control thrust percentage. I will use turn variable to steer with the plane left or right, and pitch variable to raise or lower nose of the plane. Let's assign values to those variables proper way. You will notice that turn and pitch for this plane is the similar as steering and the throttle for car, and forward for thrust. I will use one more variable, throttle, just for convenience. So I will multiply value of forward with time dot delta time. and then clamp that value between 0 and 1. Because for the plane we don't need -1 value, since we are not going to go to reverse. Then we will calculate speed as rigid body dot linear velocity dot magnitude, and forward speed as a vector product of linear velocity and forward parameter of rigid body. Just to remind, we are calculating all of these values every frame. So difference between speed and forward speed is kind of intuitive. Speed is movement of a plane in any direction, and forward speed is just a forward part of that speed. So when plane goes completely straight, those speeds are equal. And when plane is turning or climbing or falling, forward speed will be lower than speed. Speed that we calculated is in meters per second. So we will multiply it by 3.6 and like that assign it to text component of speed text field. Let's fill out other two fields. Thrust field with thrust percentage. We will calculate that one very soon. Let's calculate altitude. I will do that as current position of a plane minus starting altitude that we calculated at the beginning. And like that assign it to altitude text field. Now I will invent thrust increment variable. Simply, when we raise or lower our thrust, we will do that by the value of this variable. And we need to define thrust percent variable. And every frame I will just adjust thrust. Now let's make procedure for adjusting thrust. It is simple. When user presses R, that means when forward variable is larger than 0, and if thrust percent is still under 1, we will raise thrust percent by thrust increment. Similar for lowering the thrust. When user presses F, variable forward is lower than 0, and if our thrust percentage didn't reach 0 yet, we will lower it by the thrust increment. So our thrust percent value is between 0 and 1. So I will just multiply it by 100 and like that assigned it to text field. And let's see what we get. Let's attach our script to the plain game object. Drag text fields to their respective fields in the script. Then add player input component to our airplane. The same way as we did it for the car previously and for a truck. Define actions on move and on thrust. Okay, let's try. Now when I press and hold R, our thrust percentage goes up until 100. And when I press and hold F, our percentage goes lower. So that part works. Now let's try to make this airplane moving. Go back to our fixed update loop. After adjusting thrust, we need to add force, add lift, adjust pitch, and adjust turn. Let's make all of these procedures. We need new variable. I will name it max thrust. This is one of the variables that I mentioned at the beginning. I was experimenting a lot with these values and in the end found out that value of 1 million will work for us best for our plane of 50 tons. To make our plane move, to maintain speed, adding thrust is simple. Rigid body, add force, transform forward, times throttle, which is between 0 and 1, times max thrust and times thrust percentage. Now if we leave it like this, it will work, but our plane will accelerate infinitively. We need to add kind of air resistance, which in aviation field is called drag. And drag is calculated as speed square times drag coefficient. So now we are adding negative force times speed times drag coefficient. Again, drag coefficient is one of those variables. I did a lot of testing with my model and in the end found out that if I want to maintain maximum speed at around 900 kilometers per hour with full thrust and 50 tons plane, my drag coefficient needs to be around 15. There is some error. Okay, let's see what we got. Let's go with full thrust and see what happens. We are reaching maximum speed at around 550 kilometers per hour. That's because we are still not in the air and there is a friction with the terrain. Okay, let's try to make this plane fly. Let's fill our adjust lift procedure. More variables. We are going to need pitch angle and roll angle later. So we need to add some lift. Let's make local variable lift. By formula, lift is calculated as speed squared times lift coefficient. Again, for the lift coefficient, I had to do the same as for the drag coefficient. Probably your coefficients will be different than mine, depending on your model, on your mass. So lift coefficient that works for me is around 9. Now when we calculated this, we can add this force to rigid body, but now we are multiplying it with up direction. I will also do now some basic pitch movement. Pitch angle is actually rotation of our plane by x-axis, and it's negative when plane goes up and positive when plane goes down. This line is just adjustment when rotation is above 180 degrees. And then, depending on our user input, when it's different than 0, we will add relative torque. Rigid body dot add relative torque. Right direction, which means we are rotating around x-axis, times pitch power. Pitch is our user input, and pitch power is again one of those variables. And then when pitch is equal to 0, which means that there is no user input for pitch, we will gradually stop angular movement using lerp from current angle to zero angle. Now to define pitch power. For me, value that works best is 3 million. I made a mistake here, I was multiplying with lift coefficient 2 times. And let's see what we have now. Let's go full thrust. I am constantly pressing W now, trying to pitch the nose up, but we are still not flying. One problem is there is no enough lift force, and another problem is we cannot really pitch nose up until we are on the ground. When we reached around 700 kilometers per hour, we are lifting up, but natural takeoff speed should be around 250-300 kilometers per hour. So we need to make some adjustments to our code. At least when we are in the air, we are reaching our maximum speed of around 900 kilometers per hour. That part looks good. Back to our script. First, I'm going to limit pitch angle. Local variable limit pitch. Default value 1. Then, if pitch angle is going under minus 30, while user is pressing W, limit pitch will be 0. And similar for other limit. Then we will just multiply relative torque with limit pitch variable. We need to add one more line to stop rotating when limit pitch is equal to 0. Same command as the one when there is no user input. Now I want to increase lift force when pitch is applied. I will not use correct physics now, I will just fake this. Let's define pitch factor. Its value is going to be between -1 and 0. So if pitch angle is minus 30, pitch factor is going to be -1, and if angle is 0, factor is going to be 0. Then we will define a lift multiplier. Value of this variable will be 1 by default, plus pitch factor times 7. I put minus here because pitch factor is always negative, so this value is going to be always larger than 1. And I put times 7 because again I tested it many times to see which value is going to work best for me. And in the end just multiply lift with multiplier. Let's see what we got. Full trust. I am pressing W to raise the nose of the plane. Now we can see that the plane is taking off a lot earlier. One more thing I want to do. I will increase pitch force while plane is on the ground. So let's go back to our script. Now I will invent new type which will tell us status of a plane. Is it grounded or is it in the air? Then define a variable of that type. Let's name it state. And at the beginning, that state is grounded. Then every frame we are going to check if altitude of a plane is less than 1. And if altitude is less than 1 and airplane is in the air, we will change it to grounded. There is a typo in the altitude. And similar other way around. If altitude is larger than 1, we will say that our airplane is in the air. Then what I'm going to do with this information? I will make a local variable grounded pitch, which will be 1 if the airplane is not grounded and 2.5 if the airplane is on the ground. And multiply torque with this factor also. There is some error again. Same typo. Now should be okay. And let's try it again. Now you can see when I'm pressing W how nose of the plane is trying to go up. And we got takeoff at around 350 kilometers per hour, which is more natural. So I will leave it like this for now. This looks fine to me now. You can also see how when I lower the thrust, speed immediately goes down, and at some point even altitude will start to decrease. Okay, this works fine for now. Let's make this plane turning. Let's add some roll. This part is completely similar as before. First, we calculate roll angle, then we adjust it if it's higher than 180 degrees. Let's define roll power. Value that works for me is around 300,000. And when plane rolls, it's supposed to turn, so we will define turn power with a value of 10 million. Typo again. Same way as we did it for pitch, we are going to limit roll angle. I will limit angle between -45 and 45. And again, same way, I will add relative torque. Just this time, we are going to rotate around Z axis. And now, depending on the value of our roll angle, we will make our plane turn. So we are inventing new local variable turn amount, something as a factor. And add relative torque to our airplane. Now we are rotating around y-axis. Times turn amount times turn power. I have noticed mistake here when calculating roll angle. It is rotation by z-axis, not by x. Let's try it again. Now in our scene I will show ground from the top and select airplane, so we will have better idea how our plane is turning. Now let's level our airplane. Now when I press A, our plane supposed to roll on the left and to start turning. At the same time, by pressing W, we can try to raise our nose up and make turning sharper, which seems okay. Again, if we want to make this airplane to look completely natural, we need to play a lot and test with those coefficients and forces. But anyway, right now I'm happy how this airplane acts. One more simple thing I want to add, turning on the ground. So all of this rolling and turning I will make possible only in case when our airplane is in the air. Else, when it's grounded, I will make turning possible only when plane is moving, so when speed is above 0.5 and before speed reaches some limit. This turning we will make much more simpler. We will rotate the plane at some specific angle, which depends on steering power. So rigid body, move rotation, rotation times that angle that we just calculated. I just need to define this steering power. 5 is going to be enough since now we are not going to work with torque, only simple rotation. Let's see what we got now. I will not go full thrust now. I want to see how this airplane acts on the ground. It looks nice in the air. One last thing, landing. I don't have any special setup for landing. In theory, landing should be done around 200-250 kilometers per hour and with 20% of the thrust. I will try to do that now, but it's very difficult. If you have any recommendation for the landing or any ideas to improve this, let me know in the comments. This will be all for today. Thanks for watching.